Good morning. In this short mini lecture, I'd like to dig into what a mini Conda or a Conda environment actually is, and then also look at how we can specify them in the kind of most ergonomic fashion using environment.yml files. Prerequisite of this lecture is that you have already installed Miniconda 3. You can do this by yourself, or you can do this along with the other VXUni short lecture on the topic, which I will list in the lecture notes on the website. Anyways, let's start. Okay, so what are these environments and why do we need them? So as you will have seen in the other video, there's an amazing Python ecosystem available full of numerical and visualization and machine learning packages. The only price that we have to pay for that is that we have to manage these dependencies on a per project basis. And this is exactly what Conda environments and also other environment systems like the default Python virtual environments and also systems like pipenv and also Poetry, that's what they support, is how we can specify at the top level what dependencies a specific project or a specific application may have. So as I also explained in the previous video, we have chosen Conda for this specific series of lectures because we are focusing on data science and scientific programming, and there Conda is quite strong because they have binaries of most of these packages. Pip is catching up, I have to say, but so far because of Conda's focus, this is still, I think, the easiest way to approach your scientific programming problems. Okay, so let's have a look at creating such an environment manually, just to see what it's like. So there we go. So let's just see what we have available on this machine. Okay, no. So we can create a new environment called, so that's conda create -n for name, VXUni. Very importantly, I have to specify a Python packages or a version of Python to put in there. I could also add more packages like this. And you'll see that Conda there says it's solving the environment. What it's doing, it's going from my top level dependencies from Python 3.6 and from the NumPy that I asked for, it will try to find the newest version. And there is a list of other packages that those depend on, that, well, at least NumPy depends on. And there's some default packages that Conda likes to install in all of your new environments. So I just say yes, and then it will proceed downloading the packages when required, but Conda maintains quite a large package cache on your machine. So in general, after some use, it will be able to find most of these packages. It will be able to find them in your cache and won't have to touch the internet. Another huge advantage of Conda, this has happened to me before on an airplane somewhere over the ocean, is that you can run it in 100% offline mode, in which case it will try to resolve all of your dependencies based only on your package cache, which is terribly convenient when you don't have internet for some other reason. Okay, so now we have created that environment, and now we're going to activate it and just see how it works. So let's just clear the screen, and I go conda activate, and then I have to type the name, conda activate VXUni. As I explained previously, you can now see there in the prompt that is active. So when I now go conda list, it will show me a list of all packages in this environment. Importantly, if I type which Python, it tells me here that the Python that's using is the one in the virtual environment. Okay, so let's just make sure that we touch on everything. Okay, so because this environment is now active, it's now very easy for me to, for example, say conda install IPython. Let's say I need that. It's I think a better shell than the default one. And I just do conda install IPython, and because this environment is active, it assumes that I want to install this in the currently active environment. If the environment had not been active, I would have to specify more arguments, more command line arguments to tell it in which environment to install. Let's do that. And while we're at it, let's also install, using pip, the request package. So the nice thing about this is that Conda also supports pip packages. So you can intermix these, and this is usually quite useful because for the packages that Conda does not have, you can always fall back to pip. The same rule is active here. is that if I now type pip install requests, it will automatically install the request package into my current environment. So it's complaining here about Cython. Let's not worry too much about this. MKL, these are the Intel numerical libraries required by, I think, NumPy in this case. We can fix that by just installing Cython, but we'll fix that in the next section of this lecture. Let's have a quick look. This is a fun thing to do. So let's just test that that all of this works. I start IPython. So that's obviously in my current environment, and then I should be able to import requests. And just to show you, whoops, if I ask sys.modules where requests come from, you can see clearly that it's from the VXUni virtual environment, which is exactly what I want. Just to make this complete, I'm going to quickly use request library, and I'm going to talk to the GitHub API. I just want to find out how many other GitHub users are there with most probably the same surname as I have. So here I get a list of the first 5 of them at least. There's Ray, but I have no idea what that is. We don't, well, yes, we do have a secret organization, but we're not allowed to talk about that. But I can see that there are in total, there are 210 users on GitHub that whose usernames contain the subphrase Buerta. So that's most probably clan members of mine. Let's get out of this. Just to show you that once we're done and we want to go back to the default system Python, we can just go Conda oops, you have to, sorry about that, Conda deactivate, and you see what happens now is that the prompt does not show that the name of that virtual environment anymore. Let's have a look. We've done that. Okay, let's just take a quick look at what is actually happening here. So if I go to miniconda, and within that the envs directory, there is a list of subdirectories, each subdirectory corresponding to a virtual environment or a Conda environment. So let's go into VXUni, and what I'll see in here is I have a little mini ecosystem with its own Python binaries. See what they look like. And we can see here that, well, there's the Python 3.6 binary, and I'm not sure if it makes a hard link or how Conda does this, but it will use different mechanisms on Mac and on Windows, of course, to do that. But for us as users, we need to know that there's a directory here, and that directory contains a whole libraries and binaries collection. So if we go into lib and then into Python 3.6 and site packages, I can see here all of the packages that I've installed. So in here I can see, for example, there should be IPython. And I can also see that the requests I installed are also here, and a whole bunch of other dependencies. Okay, so that's how that works. Back to our code directory over here, getting ready for the next step. Okay, so that's how you would go about creating a Conda environment manually and installing all packages, but this is of course not a very scalable or even ergonomic approach, because what happens if you need to install your environment on a new machine, or you need to transfer it to somebody who you are collaborating with. So in order to address that issue, Conda supports environment specifications. So let's just activate our environment again, and then tell Conda env for environment export. So what we see here is Conda will now go, and it's generated this YAML file, this YAML specification, with at the top the name of the environment, the channels it's using, we can ignore these for now, and then a list of Conda packages with exact versions. This is pretty useful if you would like for someone else to reproduce your exact environment on their side. And here right at the bottom, you can also see that that we have the pip dependency specified. So those can also go in there, which is really nice. Okay, so that's how you would go about transferring this exactly. In practice, what we do most often is that we handcraft the environment.yml file. Let's take a look at that quickly, what that looks like. So I will put this on the GitHub and you'll be able to get to this. So what I've done here is instead of typing conda create -n vxuni and then installing packages Python, Cython, IPython, and then the 2 pip packages, I just put these in a YAML file. And as you know, YAML is quite simple. I have a list under dependencies with the packages and then a sublist under that with the pip dependencies. So how I use this is very simple. Let me just destroy my environment. I don't destroy environments that often, so I have to look it up in the cheat sheet, which you will also get, obviously. Oops, let's just see what happens. No, I have to deactivate it first. And then I can remove it. Okay. So now I have my environment file over here in this brand new directory, which you will also get. And let's say this is usually at the top level of a project. What you will see in the Conda documentation is that they then explain you should use conda create with this environment file. But what I found in practice is that the conda env update command is far more useful. I'll show you why in a second. So let's just do conda, let's just make sure conda info envs. And you'll see that vxuni is not here anymore. So let's just go conda env updates. And because I've called the file environment.yml, which is the default, and it's in my current directory, I can just do conda env update. I don't have to give the -f parameter. Pressing enter there, it automatically finds the file, the solver starts, and it will now, because I don't have a vxuni environment, it will create that environment and then install the packages in that environment. But what's terribly useful about this is that if the environment had already existed with packages in it, it would only have ensured that the packages specified in my environment would have been added to my pre-existing environment. We can test that. Or I will just show you that if I now, well, I don't have to activate the environment, but I can just rerun conda info envs. You can see that vxuni is already there. I can just run conda env update again. And you'll see in this case, it figures out that all of the packages specified in the environment, they are already installed, so there's no work to be done, and we're done. But the nice thing is I can now go and I can add something. Let us, oh yes, we had requests, like that. So remember, I deleted my environment that also had the requests package in there. I've just updated the environment.yml, and I just have to run conda env update again. And again, it knows the name of the environment, it knows the packages, but it will figure out that the environment's already there, most of the packages are already there, and the only thing it did extra, too much output here, there we go, collecting requests, it only added the request package. So that's terribly convenient. That's how, in practice at least, in most of my live projects, that's how we do it. So we word to the wise, you do version spec as many as possible as you can at the top level packages, but it's a bit more convenient only specifying the top level of what you really depend on, because as you change versions, it could be that some of your packages change their dependencies, and then that complete environment that we exported will not be well, it will still be valid, but then it will try to override the dependencies that have been specified by a new version of the top level. So we tend to specify only the top level packages and their dependencies. Whilst we're developing, we're a bit more loose with this, so that we sort of profit from package updates as we go along. But the closer we get to production and to actually shipping to the customer, then we start pinning down those versions to be able not to introduce any unexpected behavior in our pipelines. Okay, so I think that about covers it for mini-Conda environments. You'll find this whole overview of this whole summary you'll find on the website, on the lecture page, together with a video, and the GitHub will have the environment.yml. Henceforth, I will make a small GitHub repos for each of the mini lectures that I do. Thank you very much for your attention.